Hi and welcome to the first video on chapter 5. In this chapter we're going to be looking at calculus, differentiation, and a few other things surrounding that. So enjoy, strap yourself in, it should be a lot of fun. Chapter 5 is basically all of the skills involved in calculus, so the applications and kind of working out where this sort of fits in will come a little bit later. First, a couple of things that you just need to remember or know. Is that if something is called a constant, that means that it's a fixed rate, it doesn't vary. So for example, y equals 3 or x equals 7 or something like that. Okay. The average is often this means the average rate of change or average rate between the 2 points, whereas instantaneous is kind of the rate at one particular point, one particular instant. So the average can often be referred to as the chord, so the gradient of the chord between two different points, and the tangent, the gradient of the tangent is referred to often when we mean the instantaneous rate of change. If something is, if a graph is continuous, it means that the graph doesn't have any breaks or jumps. So for example, I've got this hybrid function here, and we'll be looking at hybrid functions a lot more. So when there's I guess two different types of graphs, depending on the domain. This hybrid function here is not continuous because when x is -1, the graph doesn't exist. First of all, it doesn't exist, and second of all, it doesn't sort of flow nicely together. You have to take your pen off the page when you draw it, because you won't be able to draw the entire way along. So at this point, if a graph is not continuous, at the point that it is not continuous, it does not have a gradient. Because we can't sort of, to work out the gradient, we need to make reference to that point and then the very next point as well. And in this case, it is not going to work for us. So we can say that the point where the graph is not continuous, the gradient is not defined, or it's undefined. Now, there's a couple of conditions for continuous, and I can explain these a little bit later. But first of all, the point needs to exist. So, when you sub in a, you should get a value. So for example, in this case, it's not continuous because if I sub in x equals 1, it's not continuous at that particular point there. Okay. The second one is that the limit exists, and we'll talk about limits in just a little bit, but it means that I guess you can approach from the left and from the right at a particular point, and you'll approach the same value. So as I approach -1 from the left and as I approach -1 from the right, I should be able to get the same value with this. And so we'll have a look at these conditions a little bit later, but these conditions are the way of deciding whether the graph is continuous. Most of the time you can just look at it, but sometimes you can use those things there. And that's the first, I guess, condition that we look at, whether something's, you can get the derivative of it, and then the second one is whether it's smooth. Smooth means that the graph does not have any sharp points or edges. So for example, I look at this graph here, this hybrid function, just two linear lines. It has a sharp point at the point 1, 4. So at this point, when x equals 1, there is considered no gradient. So therefore, at the point where the graph is not smooth, the gradient is undefined. Now, at this point, I just want to show you how to do these kinds of things on your calculator. I want to show you how to find the derivative of these graphs, and also how to put in these graphs as well. So if we jump to our calculator, I'm going to show you how to put in a hybrid function. So I guess I'm just going to say define, and I'm going to define it as f of x, and it equals, and then I'm going to go to this button just here, and it gives me a whole bunch of options that I can choose from. I want to put in the function that we were looking at before, so I'm going to click this button just here. There we go, and I'll put it in what we had before. So what was it, x plus 3, and when x is less than or equal to 1, and I'll put in the other one. You'll be able to see that, and it tells me that it's done. Okay, so now I can go and graph that graph if I want to. So add a graph page, and I'll just type in f of x there, and that's what it looks like. Okay, if I want to get the derivative of these graphs, if I want to get the derivative of anything, I guess I can push. There's a couple of ways of doing this, but the quickest way that I know is to push shift minus. It should work. There we go. Just taking a little bit of time. And I need to tell it what I'm finding the derivative of, which is x, and then I can just put in my graph here, and that will give me what the derivative is with the current domain as well. Okay, so that can often be very handy. And if I want to draw, that graph, the derivative of that graph as well, I can just put in the diff, which again is shift minus with respect to x, and then I'll put in f of x as well, and there it is. Now I'll kind of go into that a little bit more later on, but I just thought at this point it'd be nice to kind of show you how to put hybrid functions onto your calculator, because that is very handy. So thanks for watching this video. The next video I'll look at a little bit more limits, which is sort of the second part of 5.1. So thanks for watching.